All right. Good afternoon, Tech Ed. Welcome to our session on troubleshooting application compatibility issues with Windows 7. Somehow it managed to land a 300 level. I don't think that's going to be quite correct, so let's go ahead and fix that. And we'll do a, there we go, that's much better. All right, we'll just call this client 511. My intention is to show you how to solve the nastiest, gnarliest problems that you could possibly ever come across using the tried and true techniques that we use when really solving these problems. To give you a bit of background on who I am, my name is Chris. I work with the Windows team and have been solving application compatibility issues for more than half a decade now. And starting back in the Vista days and working in Windows and in IE and in Office, and I own it from the enterprise perspective. So I actually go on site with enterprise customers and sit down and troubleshoot your real problems. So I do get to escape the Redmond alternate reality vortex and see what really happened to you when we came in and said, you know, everyone doesn't really need to be an admin anymore. I can't imagine why that would be a problem. Now what we've put together today is a series of true case studies, actual applications that we solved. Fair warning, they're not the easy ones. Most of the issues you come across are far, far easier, but what I hope to show you is that by applying a way to focus your thinking, you can solve even the hardest of problems. Now, before we begin, I did want to take a moment to have a brief word from our sponsors. So this session will be sponsored by the Windows team. And here we go.
Hi, my name is Abby. I like debugging programs. One day during my homework, I thought, what if I had an operating system that stored the handle to a debug object in the thread environment block to provide native support for debugging. So I invented Windows 7. It lets me debug. Uh-oh, this program is broken. Oh, it's still user mode. That's baby stuff. Really?
I assume all of your daughters do that too?
See? Easy. Windows 7 was my idea, so give me $100 million.
All right, a big thanks to my poor children who I subject to things like that. But one of the takeaways that we'll have today is we'll show you that indeed, if it's easy for my 21-month-old daughter to debug an application, you can be able to do the same thing also. So before we begin, I kind of want to give a little bit of an introduction, kind of what's the main pushback that we're hearing, and a lot of it is the, well, Windows XP, it's good enough. You know, really 9 years is not that long. They're kind of almost the same, aren't they? Which is somewhat like saying, oh, Windows XP, that's kind of the same as Windows 3.1. That came out about 9 years before that, which was kind of the same as saying, oh, Windows 3.1, I don't see how that's different from my old Commodore 64. Turns out 9 years is a fairly impressive amount of time, and a lot of change can go in there. But that doesn't mean that when people come at you and say, oh, you know what? Would you drink a 10-year-old glass of milk? Which was an actual marketing campaign that some of the local subs put together. And my response to that is, I'm pretty sure I wouldn't drink a 10-year-old glass of milk, but Windows 7's about, you know what, 2.5 years old now? I wouldn't drink a 2-year-old glass of milk either. So when I think of it, I think more in terms of, what was it designed for? And like any other work of engineering, Windows is designed to be supportable and maintainable for a particular amount of time. So take, for example, some of the buildings that they built for the 1904 World's Fair in St. Louis. They were designed to last for the duration of the fair. They were to look like these impressive, long-lived structures, much like you would see in, say, the Greek Parthenon, but they weren't designed to last nearly as long as the Greek Parthenon was designed to last because it costs too much to design it to last that long. They were designed to live for about a year. They were made out of plaster of Paris and hemp. I like talking about that because you seldom get to bring up hemp in a technical conversation. Designed to last for a year. And that's how software works also. Our software tends to be designed to work for about 10 years, for that's how long we support it. So it's a fairly good judge of how long you think it's going to be there. How much mainstream, how much extended support do you get as an indication of how long you should expect us to be able to keep that running and effective for you. So when you come across applications that look like this, guess what? Probably not designed to be working until now. This is an actual in-production application as of about a year or so ago that I came across. On Access 2, no less. At the same time, we don't want to say, oh, applications, they get old, they expire, you need to be constantly getting new one, because that's the real value. I've not heard anyone say, oh, I just love my operating system as an operating system. You know what they love operating systems to do? Run their apps. You know where this quote comes from? It comes from Jeff Richter's book for Windows 3.0. And the same holds true today. There's value to your business in the applications you have that you want to maintain. At the same time, you don't want to expect that something engineered to last 5 years can last for 15 without any ill consequences. It's all a big balancing act. And when addressing application compatibility, the other important point is to stay focused on that which really matters. It's really easy to focus on things that don't matter, as this sign indicates. And the way that I like to phrase it is, be mindful of having a couple of lines in the sand. So people ask me, what's your number one tip? And one of the things I always say is, make sure that you're not treating AppCompat as a tax that you must pay, but as a risk management exercise. When you think about what your IT department is going to support, there's a line in the sand that you draw that says, below this, I'm not going to support you. If you come to me and say, I have a problem, my World of Warcraft is not working, that's not a problem you're probably going to solve. There's that first line. But there's a second line that's worth drawing that says, listen, I'll care about you. If you call me, I'll fix you. But it doesn't make sense for me to go in every single time I make a change and look at you, because the cost of failure multiplied by the probability of failure is less than the cost of testing. So I should just let it fail, have them call the help desk, the same way you do today when something fails on XP. It's not as if you don't know how to handle failure. So before we kind of get into some of the troubleshooting examples and demos, I wanted to quickly go through some of the FAQs that I usually get to kind of address those head on. Number one is 64-bit. Should I go? Should I not go? Should I even have a 32-bit image? What's going to break? Probably the number one source of things breaking on 64-bit Windows 7 is people who still have 16-bit binaries. And yes, a lot of people still have 16-bit binaries. Or 16-bit installers. That's the real annoying one. You know, I talk to the folks at Flexera Software who say, you know, our number one competitor is ourselves. Someone buys it once, and they feel that they never again need another one, and if the one they bought was back in the 16-bit days, that's what they're still making. 16-bit binaries are a problem. 32-bit drivers were more of a problem on XP. Today, it's just the, oh, I've got this special purpose dongle device used for licensing is about the only place I still see that one come up. An interesting one that I kind of didn't expect is managed code that does interop. This is a curious one. So the .NET framework, the default compiler mode is something called any CPU. It literally says, if I'm running on a 32-bit OS, I'm going to be a 32-bit process. If I'm running on a 64-bit OS, I'll magically suddenly be a 64-bit process. One of the rules of 64-bit and 32-bit processes is that you can't host a 32-bit DLL in a 64-bit process. You can't host a 64-bit DLL in a 32-bit process. They have to all be bitness aligned. If my .NET code is magically promoted to 64-bit, but it does pinvoke or com-interop or something else to get some existing native code, maybe some VB6 code inside of it, suddenly it's going to fail. Conveniently, there's a utility that distributes with the SDK called core flags, which lets me go in and change that bit, forcing it to be a 32-bit app without having to submit it to be recompiled. And last is the differences in paths. And what really becomes problematic here is when you mix and match. So if I look at, hey, I want to write 2 program files, and someone says, oh, there's an API that will tell me where program files is, I'm going to follow the rules and ask the API, then I'm in great shape. If I just type C:/program files, then I'll be looking in program files. If I call the API and I happen to be a 32-bit program running on 64-bit Windows, the API will return C:/program files, parenthesis, x86, unparenthesis. Those are different. If I always use the API, I'm good. If I always use a hard-coded path, I'm good. I'd like you to fix it, but you'll still work. It's when you mix and match that you get in trouble. Some things are calling the API and doing it right. They're looking over here. Other parts of the program are hard-coding it. They're looking over here, and suddenly I have a problem. We can fix that with the infamous correct file paths, which we'll be looking at today in some of the demos. On the VB6 side, there's a little bit of confusion, so I'll just quickly dispel that. VB6, the runtime is part of the OS, supported as part of the OS. There are components of the runtime that you have to install manually. Those are mostly the OCX or ActiveX controls. But they're still supported. Include them in your installer, so you have to repackage those if they're not already there. There are components that are not supported. As a general rule, the ones that are not supported because we didn't make them. We licensed them, we shipped them. The reason why we don't support them is not because of some organizational arrogance of, oh, we'll only support stuff we made because we're better, but rather because we don't have the source code. So we can't do anything to fix them if you find a problem. So it's kind of irrelevant whether we would like to support them or not because we have no means by which to support them, I guess, other than manually editing the assembly language, which is kind of an expensive thing to do. When we talk about fixing applications, we're going to look at a couple of different options, but one of the things that I wanted to explain was how to shim Windows, which you can see on the screen up here. That's how you do it. Any questions? That was actually really funny. A friend of mine, Steve Campbell, was walking down the street and he saw that and he's like, Chris Jackson. And he immediately sent me a picture of that. What I wanted to do was I wanted to explain how shims work really at the deepest possible level. And if you remember, when I change that little number to a 500 level, we're going to get really, really geeky here. I hope that's okay. But I'm going to take you through, so if you're unfamiliar with some of the tools and some of the concepts, you know, I'm not going to leave you in the lurch, leave you behind. I just want to explain some of these concepts and get deeply into them. So a shim, it's a way for us to fix an application without having to go and order the developers to make me a new one. Ideally, I do that. That's always the best option, something natively compatible. But what happens if the vendor's out of business? So they're not making me a new one, right? It was a contract hire. They came in, they wrote the code, they went away, now they're gone. There's nothing I can do about it. Or another scenario I find a lot is, great, you know, we found this bug and it happens in every single one of the applications out of this division. Because as it turns out, while people are never good enough at sharing code that's good with each other, people are awesome at sharing the buggy code. And so you'll end up with this bug that's lighting up all of these apps, and they all have these long test cycles. And you're like, I don't want to wait for all of those to pass the test cycle. What can I do? I can apply a shim. And the next question comes, well, what the heck is a shim? Because up until a couple of years ago, no one had ever heard of it. It was something that we had used internally to describe, to fix applications that we were building. And we kind of put the tools out there, but tools without documentation was not terribly helpful. And I then started asking, can we please get documentation? Can we please get documentation? And I kept not getting it. And I finally figured out why. The people who wrote them are the deepest, nerdiest engineers within Windows. They're kind of like little trolls. One of them literally never has the lights on anywhere near his office. They don't write English. And we have some people who can actually write. They're fantastic technical writers. And they have no freaking clue what these things do. They don't know how to talk to each other. So I decided, all right, if no one else is going to do it, I'll do it. I'm up to about 30. Everyone always complains, oh, I wish you'd do the other several hundred. But it turns out to be a long tail problem that with that 30, you can get quite a bit done. So for those of you who are unfamiliar, or even those of you who have heard of them but don't know precisely what they do, here's the principle by which a shim works. Starting with the principle by which Windows itself works. How Windows loads a DLL. You load a program into memory. It's going to live somewhere in that memory space. Windows has a 4 gigabyte address space on 32-bit. We'll simplify it by not talking 64-bit now. And then I load a bunch of DLLs. DLLs have a start address that they prefer to start in, and you can actually go in and see that address in Process Explorer, which is a sysinternals tool. And let's see if I can find anyone naughty here. Oh, there we go, there's one. Oh, it's iframe, that's fantastic. Who are they sharing it with? Okay. They all say, I'd like to start at this address. And they all have a preferred address. And if someone's doing their job, they will go through and put it at the address that's unique in the scenario they're typically loaded in, if they're doing their job. They at least try to. A lot of people don't. A lot of people just take the default that Visual Studio or whatever compiler they use give them, and so they'll all have the same address. Because if you have a different starting address, guess what we have to do when we load you? We have to go through and update any internal links to other places within the DLL, which is kind of expensive. We don't want to have to rebase you at runtime if we can rebase you earlier on. That's good. But we never know for sure what other DLLs are going to land there. You can see here, Smidgensoft and Microsoft both asked for the same thing, coincidentally. They didn't know that was going to happen, so one of them had to move. Since you may have to move it, we don't want to hard code the addresses because they could have to move. So how Windows works is it says for this DLL, at this offset in the DLL, you can go and find that function. It's a table. It's a level of indirection. As a result, that's something we can go and change. How many of you just freaked out when I opened up WinDBG? Anyone? I can't actually see a thing here. A lot of people see a very low-level tool and immediately get pretty scared because it's somewhat threatening and new and novel for most people. Typically, you don't have to use WinDBG anymore because you'll use the debugger that comes with your program against source code. Way, way easier. I'm simply going to use it here to show you exactly what's happening in the computer when I apply a shim. The G function is really easy. Go. Run the program's going to run, and it's going to bring up this dialog box saying, oh gosh, I really wish you were Windows XP because it's the most awesome software ever written. I can then stop the program in a debugger and show you how it found that out. There's another command, UF, unassemble function, that will show me the contents of a function. Now because I don't like to type, I'm going to cheat and call another function before called LM. List all of the modules that are loaded. Now I can unassemble from my executable file the WinMain function, which is the entry point to every Windows program. As an indication of just how geeky I am, it's also my license plate number. Oh, I'm not kidding. My little Mini Cooper, you can see a picture of it on the web. And it's actually a fairly common starting point. I happen to know it's there because I wrote this program. What I'll explain is how can you read all this stuff. I've just dumped a pile of assembly language onto the screen, and even people who've seen assembler are usually like, yeah, I've seen assembler in the 70s, back when you had to. I don't see it anymore. It doesn't really matter to me everything else that's happening here, right? This is even too nerdy for me to care about. What I care about are these patterns. Call, call, call. This call function calling, that's the function I'm interested in. Get version EXW. That's how a call to Windows looks. Windows to the user, well, little fancy glass borders, things like that. Windows to a program is just a bunch of DLLs and a bunch of functions that I can find by looking for a call. Call this function from Windows and do some work for me. And notice that this is closed in brackets and it's saying call whatever this is pointing to. It's a pointer. So whatever address is at this entry in the table, call that. I can use the DDS function, dump the D word as a symbol for what this is pointing to. What is that function? Let me actually just do one symbol. This is pointing to a function in kernel 32, which I would expect, right? Here's the table. The table is pointing to kernel 32. That's exactly how it works, so I'll call what's in kernel 32. Now let's shim it. So if I go into apply a fix, and I'll just go into, call it star, it's by me, program files, it's from the stock viewer demo app, the GWM compositing rendering demo, and I just want to do a WinXP, SP2, or SP3 versionalize so that it thinks it's running on XP. Then it gives me the files to match it. If you have not seen this tool before, this is Compatibility Administrator. It's a tool that comes free as part of the Application Compatibility Toolkit that lets you create your own custom databases. The shim infrastructure itself lives and ships as part of Windows. The shim database of things we've already fixed with this technology ships as part of Windows and updates via Windows Update. The tool that lets you make your own is part of the Application Compatibility Toolkit. You can install it separately, or you can even X-copy the binaries. It's actually a fairly simple little program. So I'm going to make this, and I'm going to call this AU TechEd, drop it on my desktop. And I'm just going to put a version lie to say, pretend to be Windows XP when I run you. Shims are applied when you launch the program. The loader, it's actually kernel 32, bang, create process internal W. So it's when you load it. So if you're experimenting, you've got to kill it off and start it again to see if it works. .restart is how you tell the debugger to restart the program. So we'll restart the program, we'll wait for it to reach the initial debugging breakpoint, at which point we'll say go, and now we'll get the fabulous star showing again, what a fabulous program this is. If we stop it in the debugger, here's what we've done to the program. I'm going to unassemble the function again. What you'll notice is the function itself didn't change. We didn't change the program on the disk. We didn't change the program in memory. All we did was, boy, that's taken a long time. What we did was change the address in the table. So now it's pointing somewhere else. That is taking a ridiculously long time. That is so not helpful for my demo. demo gods, what have I done to disservice you? Well, we'll let that run and we'll come back and finish that off because I don't want to spend the entire time going into the bowels of shim internals, but I did want to explain a bit about how they worked, and we'll kind of come back and close it off as we go. And I wanted to spend the rest of the time talking about case studies of troubleshooting applications, some of which we fixed with shim, some of which we fixed with other techniques, but to go through the troubleshooting process. Now the troubleshooting process, there are a couple of different ways. One way that I like to express it, which I've taken directly from the approach advocated by John Robbins, who's probably one of the best teachers of debugging that I've ever come across. He works for Wintellect. He advocates this process, multiple steps. First, duplicate the bug. I can tell you right now, the number one problem we have with getting bugs fixed for applications or for Windows itself is they get closed as no repro. No one has any idea why it's happening, but they can't make it happen. And if we can't make it happen, we can't fix it. With a reproduction, then go through and describe the bug. What is it that this thing is doing? Help me understand. Clarify the problem to begin to see what the solutions might be. Don't forget to assume it's probably your app's bug. That's more likely. Then start thinking about hypotheses you can come up with to divide the problem into a smaller subset. You'll start off with, hey, it could be anything in the whole big wide world. How can I eliminate half of the everything to get down to half of infinity, a quarter of infinity, an eighth of infinity, until I eventually get down to the one thing that is the problem and know how to fix it? Stop and be creative. Debugging is not just science. There's a bit of art to it. And you can come up with fairly clever solutions if you allow yourself the opportunity to be that creative person. Then go in, take the tools, see if there's any shortcuts you can do beforehand. Then and only then, if you're left with no other option, you can start doing some of the gnarlier debugging. And when you're done, ensure that you are actually right, prove that you were right, and then write up what you've done, figure out a way to share it. I personally blog a lot of my nastier issues because the number one consumer of them, I'm reasonably sure, is actually just me. Oh, I'm seeing something like this before. Oh, I'll just do a web search on it and go find where I've done it before. Some of these are really easy to lose track of. So when I look at making sure we utilize the tools and we think creatively and understand the problem. I had a session that I gave for a bunch of Microsoft internal people, so it kind of became a little bit of a geek competition. And someone said, hey, I've got a web app that's not working. Can you take a look at it and see what the problem is? So we threw it up, and I, of course, want to say, oh, let's see if I can blow this guy away and fix it in a couple of seconds. Wouldn't that be awesome? And I started tearing it apart in the debugger, and I was like, ooh, this is gnarly. This is nasty code, really hard to figure out what's going on here. And I said, rather than sitting here, watch me debug, which is really boring to watch debugging in real time. It's much more fun to watch accelerated debugging. Why doesn't someone else take the problem and sort it out and come back and present it tomorrow? And my friend Gary raised his hand and said, hey, I'm in, I'll do that, that's easy. He took it home, and you know what he did? He correctly understood the bug first. He didn't dive into a debugger. He didn't start poking around. He said, all right, what is this thing? And the first thing he noticed is a copyright. Ah, they took a library and reused it. Then I looked at the version number right there in the comments that I'd never looked at. Then I went to their website, found that they had a newer version that said compatible with IE9. Put that one on instead. Problem solved. I was in there at step 7. He said, you forgot step 2. Let's get that done. And even if you don't do that, at least think about it as the super simple thing of always chase a question. Don't just poke around, have a hypothesis, figure out what tool can prove or disprove your hypothesis as quickly as possible, iterate until you're done. That is the end of my boring slides. And now we'll just get into slides that talk about some of the actual problems that we've gone through and solved. Actually, before we do that, we can quickly duck back and see where we are here. Here we are in our application that's shimmed. You can see that in memory, it's still just looking for the same thing. But if we now look at what symbol is near it, AC layers. application compatibility layers. All we did was replace that one entry in a table, and now we're looking somewhere else. And if you think about the implication of that, from the perspective of Windows, the shim is your application's code. From the perspective of your application, the shim is Windows's code. Shim is one of the very rare times when something from Microsoft that's 4 letters long is not an acronym. It's literally a metaphor. A little bit of code that you jam between the app and Windows to get it working. All right, so that's enough of that. Let's take on a problem. This is a problem that actually came to me from the team that's building the next version of SQL Server. And they came to me and said, listen, we are really, really stuck. They were building the installer for SQL Server integration services. And the way that installers work on Windows 7 as well as on Windows Vista, and presumably for some good time to come, is you can mark your app saying, I need admin rights. So if you see a prompt coming up, UAC prompt, I'm guessing you've probably seen one of those. You know what makes that come up? Has nothing to do with whether or not you need admin rights. A prompt will come up because A, the developer asked for it by putting it in their XML manifest describing how the program should run. It will come up B, because the IT admin asked for it by putting a flag on there in a custom shim database saying this one should prompt for admin rights. Or C, it will come up because we think you're a setup. So we included a layer of heuristics that try to spot installers. Now, that will catch a lot of things, but the SQL Server team, as with any well-behaved team at Microsoft, is like, we don't want to rely on this little heuristic thing catching people doing sloppy work. We want to not do sloppy work in the first place. We want to mark it as something that's going to require admin rights because we are an installer. We tried to mark it, but when we did, it didn't work. So I said, all right, can you send it to me, and I'll take a look. So they sent me their installer. Here it is. This is the installer for a next generation product. I've not seen it, but they weren't really seeing much of it either because it immediately popped up this. And they said, all right, we're trying to do the right thing, but you're really kind of being a pain. There's something wrong with it. And it's coming up with this dialog box. Why isn't this working? They couldn't figure it out. They'd gone through several escalation points. They got to me and said, what's going on here? Now, the side-by-side configuration refers to the manifest. So remember our process. Hypothesis, tool, hypothesis, tool. Why isn't this working? My immediate thought was there's something malformed about the manifest. So I went and took a look at it. This is, wrong app. There we go. I said, okay, I can go and find it. So I used a free tool called PE Browse Professional. It's made by Smidgensoft. I'll give them props because I use their stuff quite regularly. This is a free download that I at one point just stumbled across, and I just periodically use it now and then, and this was one of the times when I did. You can, using this tool, see everything that's in a binary and kind of poke around and see what's going on. I use it to poke around and say, show me what's going on in the manifest here. And I took a look and I said, okay, well, here's the XML manifest displayed in very convenient hexadecimal format. I thought to myself, I don't know that I really want to poke in hex format because that's a little bit hard for me as a human. So the first thing I thought was, let me go ahead and extract that and drop it on my desktop. So I called it dqsinstaller.exe.manifest. And just put it on the desktop. So here's the manifest file, and now that I have it on my desktop, I can go and use a text editor to see what's going on. So I popped it open in a text editor and immediately saw some characters that looked a little bit off to me. I'm like, I don't know everything about XML, but I'm guessing that's not really very valid syntax, kind of hanging out there. So that was my first thought. So I have a hypothesis now. I think that you've got some malformed characters and that's causing it to behave badly. So wouldn't it be great if I could pull those out and just get rid of them? And then I was like, all right, well, I can edit that text file. That text file has the rather inconvenient property of being inside of this exe, and getting it in or out of the exe seems kind of like a pain. I kind of didn't want to have to be sitting there constantly injecting. There are SDK tools that could help me, but I didn't want to do that. And I thought, I wonder if I could save a bit of time. Remember the think creatively part? Because I'm busy. I don't want to sit there fiddling with in or out. That's not important to me. Can I save some time? And I remembered one of the rules of manifests. Manifests will be read and processed. We prefer the internal one. If you don't have an internal one, we'll read the external one. It's an important rule. This one has an internal one, so the external one will not affect it. So double-clicking on this, even though I have an external one, app.exe.manifest, it'll never be read because there already is an internal one. But then I thought to myself, what if, since all I'm doing is doing UAC elevation, I took another binary that I happen to have lying around, that I knew did not have an internal manifest, and use this manifest that I modified as its external manifest. Now I can see it right away. I thought I was pretty darn clever. And it actually works. I've now applied a manifest to that. I have, however, not fixed the application yet. So my first theory, those characters are bad, was proven wrong. So then I had to come up with another theory. The next theory I have is just based on my experience. So your experience, the more you do, the more things you start spotting. The one thing I'd never seen on a manifest in any example on the web or in any manifest I've looked at in an app is that XML comment at the beginning. And when you think about how we do XML parsing for the loader, we don't have MSXML sitting in there. Whether or not that's valid XML, I don't know. But I do know that we don't link to MSXML inside of the loader because of the layering work that we've been doing in Windows over the course of the past couple of releases, which says if you're a layer 0 component, you can depend on other layer 0 components. That's it. If you're layer 1, you can depend on layer 1 or layer 0. Layer 2 can be 2, 1, or 0, and so forth. Creating a process, pretty fundamental to getting anything done in Windows. That's a layer 0 component. MSXML, can you do stuff in Windows without MSXML? All kinds of stuff. Kernel 32 is not going to link against that. So instead, we're going to have to write our own. And if we're writing our own, are we going to write a full-featured, really rich and robust XML parser, or are we going to write just barely what we need to get it done? What if we just don't support that comments if it's too complex of XML? What if I take that out? If I do that, then when I go to launch the app, now I can read it. I have junk characters, and I have an XML comment. If I pull them out, now I have a readable manifest. I sent that back to the SQL team. The SQL team said, it works, fantastic, we're done, and solved in about 20 minutes what they had been struggling with for over a month. By thinking, by understanding your platform, and applying a degree of rigor. Follow the process, chase a hypothesis, divide the problem, know your platform. Worked really well. Let's take another one. I'm picking on all of the Microsoft guys. Microsoft Link. This was true in Office 2007 R2, or Communicator 2007 R2. Here's the scenario the customer wanted to implement. So the customer comes up and says, hey, here's what we've got. We've got Communicator 2007 R2 on all of our desktops. The help desk will get into a chat session with the person who is, having a problem, and then if they want to try and solve it, what they'll do is they'll go and connect to that person's desktop using Link. and then they want to run an elevated window. They'll have the password, so they want to put that password in and then drive fixing the problem. Right? A very understandable scenario. How does help desk elevate and fix end user computers? Problem was, it didn't work. So we had to go at the two different problems. We had to divide it into the two separate challenges. Number one, the help desk had to be able to provide credentials, and number two, the help desk had to be able to work with elevated windows. Step number one, providing credentials. You will not be able to provide credentials on the secure desktop. And they had to accept that. So let's go in and take a look at the group policies that we have controlling this. And some people get distracted by some of the very tempting sounding policies. And the security settings one always takes a really annoyingly long time to open. But the idea is we're trying to have the help desk provide the credentials. The default behavior, I had intended for all of you to come up and stand behind me. The default behavior is we switch over to the secure desktop and display the dialog box there. It looks like you're seeing your desktop there. You're not. What we do is we take a screenshot of your current desktop, we dim it, and we set it as the wallpaper for the secure desktop. All that stuff is not actually there. So we put it on the secure desktop by default, and the goal of that is to prevent spoofing. Because if it were on the same desktop, you could put other information in front of this to make it look like something else that you would say yes to. We have this very tempting sounding policy that says, allow UI access applications to prompt for elevation without using the secure desktop. I don't know if there's any group policy people here, but what I've noticed is that I honestly believe that most of the text of the group policy that lives in this console is written by someone literally just taking their face and banging it against a keyboard and picking the words that come out. So let's translate this from what they said to what it actually means. The allow UI access applications to prompt for elevation without using secure desktop actually means allow msra.exe and only msra.exe to prompt for elevation without using the secure desktop. Slightly different than what the text actually reads. So we don't have the option to have anyone else avoid the secure desktop and have that work like magic. And it turns out that how msra.exe is implementing it is by using an internal API that not even other people at Microsoft can use, or particularly other groups at Microsoft can't use it. So what we had to do for scenario number one, let you type in credentials, is to go in and say, switch to the secure desktop when prompting for elevation. Not going to do that. Conveniently, on Windows 7, to support the browser, the slider, this secure desktop thing also appears in a couple of other places in the policies. So you need to make sure that all of your policies say no secure desktop. Isn't that helpful? Conveniently, it's not the default, so you really only effectively have to change it in one place. So we had to line up their policies to say, don't go on the secure desktop, just stay on the main desktop, that way you can work with it. That was part one. That was easy. Group policy, we got it set up. They're like, yeah, we can accept that as a solution, everything's good. Step two is, starting in Windows Vista, we implemented this feature called Windows Integrity Levels, which does authorization based not just on who you are, which we've always done, but also how much you trust the process. And there are 4 basic levels that you normally see. And in fact, it's a column that you can add in and see which level each program is running in Process Explorer. Here's medium. If I were to open a browser window, that would come in as low. Here's the low for the tab process. I've got low, medium, high, and system. And that's enforced for opening files in the file system, opening registry keys in the registry. And we also implement another feature on top of this called user interface privilege isolation. What user interface privilege isolation does is it says, from a lower trusted process, you can't send window messages to a higher trusted process to avoid you getting elevation of privileges using Windows messages. Windows messages, it's fundamental to how Windows works, right? How you click a button in Windows. You click the physical mouse. That gets interpreted by the hardware driver that converts that into a Windows message, WML mouse button down or something along those lines. That gets sent to the window that your mouse is sitting on top of. You can also send your own. And Windows doesn't have authentic user gestures. So there's no way to tell the difference between one that comes from an actual hardware mouse and one that comes from another program, either good or ill-intentioned. Good if you're writing UI automation, bad if you're trying to avoid bad guys getting elevation of privilege. So we say, you know, if you're a medium IL process sending a message to a high IL window, we won't deliver it. Unless you happen to be a UI access application. In your application manifest, you can say, don't let these rules apply to me, because that's what Link would have to do. Send window messages to those windows saying, click this, type this, do all of this, the same as you would with a physical keyboard and a physical mouse. And they're going to be whacked down by the same rules saying, hey, Link, you are a medium IL process. This is a high IL window. You don't get to send messages to it. I'm just going to silently just swallow them. So we say, oh, if it were a UI access application, then you could send them anywhere. You're opted out of those rules. Now, just to be clear, if you opt out of those rules, you then have two additional rules applied to you. Number one, you have to be digitally signed, so someone takes credit for the app that is opting out of the rules. And rule number two, you have to be installed into a secure location which says that an administrator said it was okay for you to run on this computer. Link is digitally signed. I said, you know what? We really need to have a UI access tag on there, and that would work fine. And you know where that should come from is that should come from the Link team. They should give them a build that includes that so that it meets that scenario. It's really easy for them. So I sent a note off to them saying, you know, can we get an update at some point for a communicator at the time would eventually become Link that would add this UI access to do this scenario. And they returned it right back to me saying we did. I said, oh, well that kind of goes against the fact that we're looking at it not behaving the way it would if you'd actually done that. So then I said, you know, let's take a look at that. So I used a tool called SIGCheck. SIGCheck is another sysinternals tool. If you don't have the sysinternals suite, I have two tools. I have on auto run, and the rest are in my path, so they're always handy. SIGCheck lets me test for a digital signature on a program. And how many of you have heard of Mark Rusinovich? It's, I guess, round of applause. I can't see you up here. Round of applause. I've heard of Mark. All right? How many of you have picked a technical fight with Mark? How many of you have won one? How many of you have won two? I've picked a lot. I've won precisely one, and in response to doing that, he added this switch to this program so he'd never lose this fight again. /m in SIGCheck will dump the manifest. The actual fight I picked was that we actually do still read external manifest. He said, no, we don't. And he happened to have a program that he wrote, but it turns out Visual Studio behind the back injects an internal manifest, which is why it wasn't reading. So he added that, and he's never made that mistake again. The only mistake I'm aware of him having ever made. So I took a look and said, all right, behaviorally it looks like no manifest. Mark says there's no manifest. Mark is much more likely to be right than pretty much any other human. So now I'm really confused why they think it's there. So I once again turned to my friend, PE Browse. Why do they think it's there? And I looked in the resources section and I said, okay, here we go. 24 is type RT manifest, and here we are in mail slot number 2, and oh, here it is. Here we go. All right. And if I look in here, I can see I'm doing as invoker, UI access equals true. So it looks like it is in there. Then I'm like, wait a minute. Mail slot number 2, what on earth does that mean? Again, familiarity, knowing your subject matter, comes into play. If you don't, you've got to work harder to figure it out. But I noticed it was mail slot number 2. No idea what those things meant, though. So I went to my number 1 debugging tools, which is my web browser. And hit number 1, brought me to a blog. And the blog went through and pointed this out. Ah, here's what mail slot number 1 means. Here's what mail slot number 2 means. Create process manifest, isolation aware manifest. And you can read all the long and nerdy description. It eventually boils down to this. The create process API looks in mail slot number 1. The isolation aware API, which is load library, looks in mail slot number 2. So for XEs, we look in 1. For DLLs, we look in 2. So we put it in the DLL slot for our XE. Oops. So then I'm like, all right, so you've got it in the wrong slot, but you have it. Suddenly, remember, think creatively, I had an idea. Wait a minute. If you are not in mail slot number 1, Windows thinks you don't have a manifest. No internal manifest means what? I'll read an external one. Which means now I don't have to wait for the link guys anymore. Now I can say, oh, hey, here's this little manifest guy. Let me extract that, put it on the desktop, and call it communicator.exe.manifest. And if I then take this and drop it into Microsoft Link, and I put it right in here, requires admin rights, so I would reprocess it. Suddenly, I'll actually get UI access and solve the problem. And I wasn't quite there, because it turns out next that the manifest includes a bunch of side-by-side assemblies, which, since the manifest has never once been read, don't actually work. So bad things will eventually happen. I don't really want them to happen right now. So let me go ahead and exit that. So then we had to go through and remove all of the side-by-side positions from there to get down to just the part that we wanted, which was UI access. And now they can implement that without waiting for the communicator team to update. Because the problem we next had was we finally got the communicator team to understand exactly what was happening 2 days before the RTM of Link. That is not a ship stopper bug, it turns out. So it shipped. But Communicator 15 will have it right. All right, so next example. Walk through this. We're kind of just applying the same process. We're solving some pretty nasty problems. Let me show you the kinds of problems this process can help you solve. So this is a real customer application. And I was on site with this customer. They happened to be over in the UK. And they said, okay, here's our application. And you know, one of the things about debugging is it's hard. And if you have someone who will debug something for you for free, you ought to let them. So I was on site. I'm there to debug their stuff for free. So they're like, hey, let's find everything that's even vaguely broken and bring it to this guy, because what a sucker. He's just fixing it all for us. So they brought me this app, and they said, all right, here's the app. And it works technically, but if you look at the windows, right, they're not the same. And our users are really, really picky, right? They don't want things to change. And they went from gray color to this peach color. And I don't know why that would have happened, but it's just not going to be acceptable. You've got to figure out some way to fix it, or we can't deploy our Windows 7. They're going to stop the deployment, or at least try to. So I said, all right, let's take a look at it. Ask some questions, describe the problem, describe the app. All right, so where is it running? What's it running on? Like, oh, it's running on Citrix. I'm like, wait, what? How could there be a Windows 7 compatibility issue when all you're doing is showing pictures of it running somewhere else? Now I'm confused. So then you've got to start thinking of your hypothesis. I'm looking at pictures, now they're peach-colored pictures instead of gray pictures. What did I think of? Maybe there's a difference in bit depth. So I opened up a full TS connection where I could specify the bit depth to rule that out. And on that full connection, the windows still looked kind of peach-colored. Hypothesis tool, right? And now I'm thinking, right, it's not bit depth. I just proved myself wrong. I need another idea. I wonder what else would cause it to be peach-colored. I wonder if a junky monitor would cause it to be peach-colored. So I got a different monitor, and I plugged it in, and suddenly they were gray again. Just to be thorough, I then swapped out the cable to make sure it was actually the monitor and not the cable. And then I went to see this person. I said, I've got the problem sorted. And they're like, oh, what was the problem? I'm like, yeah, you had a really crappy monitor. And then they kind of hung their head in shame. And they're like, oh, okay, I'm really sorry about that. Same process. Real problem. This one came to me. An escalation of all things. That was your breather, by the way. Now we're going back into more hardcore geek action. So this is going after one of the most challenging shims to write. The thing about shims is they're this really almost magical thing that lets you fix stuff that requires an almost insane amount of intelligence to master them. Which is why I usually say it's often useful to learn how to use the easy ones. Version.ly, really easy to use. A lot of the UAC ones, really easy to use. Correct file paths, really gnarly to use. Why is it so gnarly? It's insanely literal. It's insanely literal because a memory compare is really, really fast. But going through and modifying a string to normalize a file path is not really, really fast. This gets applied to every file system API. How often are file system APIs called on Windows? Run procmon for a while if you don't know. It turns out an awful lot. So if we spend a lot more time doing work for every single call to a file system API, we will drastically slow down your system. So we're very, very literal. So here's the problem. I don't know if there's anyone from Quest Software here. This is some of their software. SQL Nav 5. So here's where they came to me with the problem. Here's an app. It's not working so well. I said, all right, let's take a look. All right, let's take a look. All right, let's take a look. Yeah, you seem to be right. That's not working really well. When in doubt, use procmon. Why the heck is this thing not working really well? Is it even launching? All right, let's take a look and see, what's going on here. So I fired it up and launched the app, and once again, it did absolutely nothing. So let's freeze it up and take a peek and see what's happening here. So I went through and applied a filter to say, show me everything where the process name is SQL Nav 5. Add that in, apply it, say OK, and let's just start fishing, right? I have no idea. It's doing absolutely nothing. But I noticed that we actually are starting up, and we're starting up at 4 minutes, 4:28 and 28.647 seconds, and we're ending at 4:28 and 28.769 seconds, so we're not terribly long-lived. My favorite part is this. Everything's okay. So I don't have any clues from the exit code, and there's nothing in the event log, and now I'm still kind of fishing for ideas. So I clicked one screen up, and I spotted this guy. Oh, you're trying to create this ctodebug.txt. You got access denied. You exit that thread, and you just start spiraling towards exiting the process. That looks like a pattern. You're trying to write there, you didn't, you got pissed off and you went away. So what can I do? I could redirect that somewhere else where I'm allowed to write it. So that's where I would apply correct file paths. So I'll point it at SQL nav, and that's by quest. And I don't want to apply an entire mode because I want to be very specific that I want to do correct file paths. I select it, and for this as well as other configurable shims, I have to go in and provide parameters. And the question that someone brought up to me in this sort of a conversation on figuring this out, they're like, do the people who write the shims and therefore implement the parsing for the command line, have they ever met each other? Not really. Every single one parses it a little bit differently. In the case of correct file paths, the syntax you use is old path, semicolon, new path. And if your path has a space, you have to quote, not the individual path as you would do anywhere else in the entire world that you would ever do this, but the entire pair. A little bit strange, but it's documented now. I want to redirect from c:\whack_toaddebug.txt to user app data toaddebug.txt. Doesn't have spaces, so I don't need quotes. I'll accept the default descriptions. It's okay if I target just that version. I don't need to use up to or including that version. I just need that one. It's the only one I'm using. And install that new database. And now let's go ahead and clear this out. Start monitoring again. Our filters will still be applied. We'll launch it and, oh, that didn't get much better. That's still doing kind of nothing. 42.44 and ending at 64, so I get 0.2 seconds and I'm dead again. Well, that's just fantastic. This time it's different though. Remember last time I went up one screen? One screen, I'm still okay. Oh, two screens up. Wait a minute. I just redirected that. There are two reasons why something won't work in correct file paths. Reason number one, the call to write has been given from someplace that's in System32 because System32 is excluded from being shimmed by default. The idea being Windows itself shouldn't need the shims. Of course, that doesn't stop other people from dropping things into System32, so occasionally you've got to include some of those. So that's one possibility. The other possibility is we haven't exactly matched it. Now, I'd like to think that I would have maximized my chance for a match because if you were watching me, I copied and pasted from procmon. The thing is that by the time you get to procmon, it's already been normalized. So in this case, I can see it's not coming from System32. It's going through AC layers on the way through. It didn't get modified, which means it must not have been a literal match. So I saw this, I'm like, all right, well, what is it asking for? And what I did, not being respectful of my own time, clearly, is I took a look at it in a debugger. And I'll tell you the reason why. I thought I could do it really quickly. The reason why I thought I could do it quickly is because the actual call into kernel 32 was for create file A, which is much less commonly called. Windows itself will always call create file W. A and W, ASCII versus a wide character. Right? So we're all Unicode internally, so Windows itself is always doing create file W, but a lot of old applications that were compiled against the ANSI version will call this. So I thought that's probably going to be fairly rare, and so I can set a breakpoint on that. So here's what I did. I loaded the program. The way that the debugger works is it always just loads it up to an initial point and stops. So you can set a breakpoint. Tell it where you want it to stop next. We haven't really started running anything yet. So then I can say, set me a breakpoint, BP, at kernel32, bang, which is how that's the module, and then bang, create file A. And now I've set that breakpoint, and now I can say go. And I get to the first instance where I'm calling create file A. And when I get to that point, I want to see what is the call stack that I currently have. So I'm going to use the K function to have it give that call stack to me. And what the debugger will give me is, hey, here's the symbol that's near it, so I'm in actual create file A, and here is what else is on the stack. The way that Windows works for the calling convention used is you load the arguments on the stack, and then you call the function. Way easier than x64 debugging, which is nasty. So I can see, oh, here's the actual argument I passed, which in this case is going to give me the name of the file. I can dump as ASCII, since it's create file A, I know it's ASCII. Whatever is in that memory location. There's what it is. It's not c:/toaddebug.txt, it's /toaddebug.txt. That is not a literal match, and therefore it doesn't get corrected. What could I do? Then I can go in and say, oh, yep, let's edit this fix, and let's change that, and remove that c:, save it, right-click install. Now I will have it applied the right way. Let me go ahead and show. Now that's going to terminate. And I fixed it. And after doing that, I thought, wow, that's going to be a kind of difficult thing to replicate for everyone in the world, right? Because, hopefully I've made it so that you can follow along as I'm exploring things with the debugger, but I'm guessing that most of you aren't going to be like, that's going to be my default choice now to solve all of my app-compat problems is fire up WinDBG and see what happens. So it then occurred to me, is there an easier way? And I had the opportunity to experiment with that a little while later. Someone else had the same challenge. We weren't correcting all of the paths, so we weren't able to get there. They reached out to me and said, can you help me do it? And this is the tool I used this time. It's a tool called Lua Buglight. Lua Buglight is a tool that is free, right? And I love free stuff because I have no budget. I'm not in sales. My friend Aaron just wrote it. I seem to attract a lot of friends like that, the kind of guys who write debuggers for fun. It's one of the things that he wrote. He subsequently wrote the Sysinternals book on all of his vacations. Guy really needs a life. Posts it for free, and he uses it to help him solve problems of applications that don't run as a standard user, but which run as an admin. And actually is a really good approach in that he tries once with the standard user token, and if that doesn't work, he tries again with the admin token, and he records the difference between the two. So I had the person who was working with this customer, they were in Jordan, and that week I happened to be in Melbourne. So we had this sort of email that we're trying to be terse because we've got these massive time zone differences. So like if you don't get it solved in a short burst of time when we're both online, we're waiting another day to get it going. I said, collect this. Because Lua Buglight, in addition to telling this consultant that her problem was in these files, she knew that. And she was trying to apply correct file paths, and they wasn't fixing them. The other convenient thing is that it also provides not just the file, but the actual parameter given to the API. So she didn't have to go into a debugger and go look like I did. So it's right here. Way easier. And she kind of went through and said, okay, c:/, that's right, c:/, that's right, wait a minute. What's that doing that way? Ah! Added that argument because it's not a literal string match. File system kind of lets you get away with it, but the shim just says, yep, nope, you're not the exact same string, so it just ignores it. Added that additional parameter and fixed the app. And didn't even have to touch a debugger. All part of knowing your tools and using them before heavy debugging. Think through all of the problems, all of the challenges, be creative, and come up with better solutions. There was another customer problem, and I've seen this one actually at a number of customers, right? People who have VB6, this one comes up, fairly regularly, which is, yeah, I've got something that's kind of hard to read. Let me show you what it looks like. You can tell me what you think about its readability. So the app looked kind of like this. And they're like, all right, technically, I guess I can read it. Right? But, that's a little bit more than I can expect of my end users to tolerate for fixing that. So the first question is, what's going on here? And when I came across this problem the first time, I was trying to think, what could I do? And sort of the first thing I did to kind of rule things out is, hey, we have some shims that fix colors. Let me just throw them at it and see if it works. Because in the end, I don't care why it's broken if I know what the fix is. And it turns out the shims didn't fix it. And I'm like, oh, isn't that inconvenient? So then I said, okay, well, let's see if I can find a tool that will tell me what's going on. And I knew that this was a Visual Basic application. And I thought to myself, I wonder if there's a tool that's sort of like Reflector, which is a really cool tool for .NET that has ceased being free, so consequently I don't have it anymore, because I have no budget, that will take your code and reverse engineer it. So I used my search engine and said, hey, search engine, is there kind of a free Visual Basic reverse engineering tool? And it turns out there is. Here's the about on it. All right, I'll just give credit where credit is due, by Sylvain Bruyere. Writes this, it's at decompilervb.net, totally free. And I said, all right, great, here's a free tool. I like free because I can afford that. And let's take a look at what's going on in here. And I'm like, I kind of poked around. I don't know how it reverse engineers it. And I said, okay, well, what is this thing? Oh, here's what we're setting the background color to, this negative number here. I'm like, what on earth does that mean? Because I don't know about you, but that negative number doesn't mean much to me. So I took a look here at this thing, and I said, oh, let's do a search, and back color, maybe that works. Let's take a look there. And let me also do, just a generic search on that term. And that's not going to tell me. The color. All right, and just kind of poked around, and I'm like, oh, wait, here's colors on this little MC computing, and oh, wait, they're doing it in hex. Let's translate that to hex. And this is kind of what I did, right? We're kind of figuring out, and I'm like, how do you translate to hex? Well, go into programmer mode, and here it is in decimal, and if I put that in hex, I'm like, oh, 8000009. All right, let's go back to our web browser, 8000009, and ooh, VB title bar text. Suddenly it made sense. What color is the title bar in Windows XP? Has it been that long? It's white. Dark blue with white on top of it, right? What color is the title bar in Windows 2000? Gradient blue with white. What color is it in Windows 98? Gradient blue with white. What color is it in Windows 95? Solid blue with white. It's been white for a long time, as long as you don't change the defaults. What color is the title bar text in Windows 7? It's black. Aha! We just chased the title bar text. It turns out that I can make this go from broken to fixed by Oh, really? Explorer's going to crash? That's fantastic. We only have 1 minute. I don't have time to debug this one. So I could go in and go into appearance and personalization, I can go into details and say, all right, let me, how do we get in here? I have to go find it. Advanced appearance settings, and I can go to active title bar, whoop, one more up, active title bar, and say, no, don't make it black, make it white. And guess what's going to happen to my VB app after I do that? Aha! Now, I think that active title bar text is really freaking hard to read, so there's no way I'm going to leave it that way. I consider that to be a non-solution. So then I have to figure out what my actual solutions are. And in this case, we said, oh, they had the source code. One after the other, they had the source code. I've asked for a shim. I can tell you, part of my job I consider is being an advocate for your needs to the product team. If you have something you can't fix, part of my job is to help you get to fix it. So I made a request, but part of the job of Windows Sustained Engineering is to change as little as possible, because every time they change something, other stuff breaks, which I get why they would do that. So I said, they said, was there anything else you could do? And in every case so far, they've been able to go and get the source code and just redo it. So there's no shim for it yet. It's always been a recompile. The other thing I had to know was, why was I seeing this so freaking often? And here's what I learned. What happened to all of the VB developers when the web became hot? They suddenly were the guys with the battleship gray, where the hot, cool web developers were the ones with the white. They didn't want to actually learn the web, but they wanted to look webby. How do you look like you're a web app? You have a white background, like the web guys do. Open VB6 on an XP machine. Click the drop-down arrow for back color. What do you think the very first white color is? We start in system colors. Active title bar text. They've literally picked the first white they saw, figured it would always be okay. You can also, if you come across it, point out that that's not a regression by going to XP and switching over to the silver theme, which has black text also. So with that, I believe I've gone about a minute over. I would like to thank all of you for coming and geeking out. Hopefully my little tour of the internals of Windows and my little examples were helpful. I wish you happy debugging, and Pete here, the debugging wombat, will be here to assist. I am at appcompatguy at Microsoft.com, and www.appcompatguy.com. Feel free to reach out to me. Have a great rest of the conference.